Hey everyone, let's look at finding domain and range. Now, before we get too deep into this, let's really quickly review what domain and range are. Domain is like the kingdom, it's like the land, the realm, just all the x values, that flat round, that flat area of x values that we can talk about. So domain is a bunch of x values. Range, on the other hand, is a bunch of y values. Think of a ranger, how it shoots his arrow upwards, so it goes up and down. Those are the sets of y values. So if you want to find the domain and range, what we really care about is the x-axis, this domain realm, and the y-axis, the height realm. Okay, so let's say we had a given problem. What's the domain and range of the points on this graph? To really do this, there's a couple ways you could think about it, but I think this might be helpful if you're still struggling, or if you are struggling at all with this kind of idea of finding domain and range. Think about the x-axis being a plane, a realm, and the y-axis being well, just the up and down the column. To find the domain, think about all of these points, all these blue points being magnetized to the domain. So this point gets magnetized to the x-axis. This point gets magnetized to the x-axis. They get shot down. This gets magnetized to the x-axis. This gets magnetized to the x-axis. And so what we get is a bunch of points. If they were all just get magnetized to the x-axis, then they would all just develop. They'd all become a bunch of different points right here on the x-axis. And so if you were to look at that more carefully, it would look something like this. This is what it would look like if they're all just shot down or shot down or up to the x-axis. They all get magnetized there. Okay, so if you were to do that, think about that first. And now the domain is pretty simple. It's just all the values that are on the x-axis. So you've got a value at -3, -2, 1, and 2. So the domain is literally x equals x, because x is our axis. We're on the x-axis. X equals -3, -2, 1, and 2. And that's it. That's done. We're done. That's all we have to do. So that's finding domain. Let's see what would it be like to find range. And range is pretty simple. Let's say we want to find the range of these lines. Instead of magnetizing to the x-axis, what we're going to do is we're going to magnetize it to the y-axis. So we're going to this column thing. So this point, instead of going straight down, gets shot right to the y-axis, and this point gets shot left. The fact that they get to the same point at the same time doesn't really matter. They just kind of merge into one. So they go into one giant point here. The 2, this one gets magnetized to 2. This gets magnetized to 0, and this gets magnetized to -1. They get shot straight left and right. Okay, so then and then when that's finished, it looks something like this. They all get shot left and right because they get magnetized to that y-axis. Okay, so the range then is just literally all of these y values. You've got a y value at -1, at 0, at 2, and at 4. So our range, because we're doing with the y-axis, we'll say y equals -1, 0, 2, and 4. And that's it. That's the domain and range for points. Now let's say it was a little bit different. Let's say we had, for example, a bunch of well, I don't know, a bunch of lines. Something, let me say something really strange like this piecewise function here. When you're doing this piecewise function, it's the exact same process, but as before, but the answer just might look a little bit different. So over here, for the domain, again, this is the x-axis. If you're trying to find the domain, you'll take all of the values, take everything, even the lines, and they'll kind of get squashed down. They'll get shot down to the x-axis. This goes down to the x-axis. This goes down. This goes down. All these go down straight to the x-axis, and this goes up to the x-axis. All of that. So they all go to the x-axis. This line over here, it all goes to the x-axis. And over here we go, all of this goes to the x-axis. So all of that gets shot straight to the x-axis. And I'll just kind of flops right into it. Kind of as if, I don't know, maybe an elephant stepped on it. I don't know. Maybe you can think of a better example than that. So if we do that, it turns into, they'll get flattened out into 2 lines that look like this. Okay. Now here's something you want to notice. On the first graph, there's this open circle over here and a closed circle over here. There's an open circle down here and a closed circle down here. Those stay. So on the right side, there's still a closed circle on the left, and up here there's an open circle. So there's an open circle over here. There's a closed circle to start off with, and it ends with an open circle. So you just want to keep those in mind. And as you might remember, if there's a point there, that means, if it's a point, that means that there is there's a point there. It actually counts. If it's a circle, that means there's no point there, so it doesn't count. So when we are trying to write this, all we're literally trying to do is just make the equations of these lines. So what is this? Let's see. To make the equation of a line, or the equation of a line segment, something like this, you would do this really fancy thing that says less than or equal to and less than or equal to, and you'd put x in the middle. And at the beginning point, you put the start point. So we start at -4. At the end point, you put -1. So it's always going to be less than, and it'll just always be less than. Now, whether or not it's equal to depends on whether there is a point here. So this is a less than or equal to because there's a point on the left side, and on the right side of x, we actually wouldn't put a less than or equal to sign. We'd put a less than sign because on the right side we have an open circle. There's no point there. So there's no point, we put a less than sign. If there is a point, we put a less than or equal to sign. And on the left side of the x tells you it's the left point, on the right side of x, there's the right point. Same thing on the right side. We'll put, let's see, we'll put an x in the middle, and then let's see, there's a point on the left side, so we'll put a less than or equal to sign. And on the right side, there's an open circle, so we'll put a less than sign. And then we'll just put those endpoints. On the left side, there's a 0, and on the right side, on the far right side, there's 4. So 0 is less than or equal to x, which is less than 4. And that is our answer. We'd say the answer is -4 is less than or equal to x, which is less than 1, and 0 is less than or equal to x, which is less than 4. Okay, great. So that is domain. How about something strange like this, and we want to find the range. The range, it's the same thing as before. We just got to squash it down. So we'll take our y-axis, and we will say, we'll just merge everything into that y-axis. So let's see, this goes to the y-axis. All of this goes straight, it gets magnetized straight to the y-axis, just like that. Now you notice that this empty point goes onto an open point, and an empty point and a solid point, when they come together, they kind of just become a point. Kind of think about like a hole, which is the empty point, being filled with a solid point. They kind of come together and become a point. The hole gets filled, so now there's a point there. So anyway, the point is this is a filled point up here once it comes to the right. On the left side, we'll get this. All this comes over as well. All of this gets magnetized over. So let's see, all that together, when all this gets squashed down, when you just compress together, what's left is this right here. There's a empty point on the left side. Is that an empty point? That's a filled point. That's incorrect. There's a filled point on the bottom at -4. -4, because that's this point down here. This came all the way over. And then at the top, let's say the top point is 5. And that's filled as well. So from -4 to 5, it's filled. And we've got a line going all the way from the top and the bottom. So it all just kind of got flattened out. It all just kind of got flattened out. I hope that makes sense. Okay, so what that means now is to define this, we just write the equation of what this literally is. Let's see, that's an incorrect equation. So we'll say, we start with -4 at the bottom. We'll start with -4, and because that's the bottom, and then let's see, there's a solid point there, so we'll put a less than or equal to, and we'll put our y, and then there's a solid point at the top, so we'll put a less than or equal to, and we'll put a 5. So our answer is -4 is less than or equal to y, which is less than or equal to 5. And that's it. That would be our range. And that's how you solve domain and range problems.